Nearly 5 decades ago, humanity launched a spacecraft that was expected to complete a relatively short mission. Few imagined that it would become one of the greatest explorers in history, traveling farther than almost any human-made object ever has. Today, Voyager 2 continues its lonely journey through interstellar space, carrying with it a small piece of Earth into the vast darkness between the stars. Launched in 1977, Voyager 2 was built using technology that now seems remarkably simple. Its onboard computer contains less processing power than a modern digital watch, and its memory is tiny by today's standards. Yet despite its age, the spacecraft continues to communicate with Earth across billions of kilometers, sending faint radio signals that take more than 18 hours to reach our planet. Its mission became possible because of an extraordinary event that occurs only once every 176 years. During the late 1970s, the giant planets, Jupiter, Saturn, Uranus, and Neptune, were positioned in a rare alignment. Mission planners realized they could use each planet's gravity like a giant slingshot, allowing a single spacecraft to visit all 4 worlds without carrying enormous amounts of fuel. This technique, known as a gravity assist, transformed what would have been an impossible mission into one of the most ambitious explorations ever attempted. The gamble paid off. Voyager 2 became the only spacecraft in history to visit all 4 giant planets. Its first encounter was with Jupiter in 1979. Cameras revealed towering cloud systems, powerful lightning storms, and volcanic eruptions on the moon Io that completely changed scientists' understanding of the outer solar system. Instead of frozen, inactive worlds, Voyager discovered places filled with surprising activity. A few years later, the spacecraft reached Saturn. Beyond its magnificent rings, Voyager uncovered new moons, studied the planet's complex atmosphere, and revealed details that had never been seen before. Each new destination reminded scientists that the solar system was far more dynamic than earlier models suggested. The mission's greatest achievements, however, still lay ahead. In 1986, Voyager 2 became the first spacecraft to explore Uranus up close. The planet appeared unlike any other. Rotating on its side, Uranus possessed an unusual magnetic field and a system of faint rings surrounding its pale blue atmosphere. 4 years later, Voyager completed humanity's first, and so far only, close encounter with Neptune. Images revealed the Great Dark Spot, enormous storms driven by some of the fastest winds ever measured anywhere in the solar system. By the early 1990s, Voyager 2 had completed every major objective of its original mission. But its journey was far from over. Instead of shutting the spacecraft down, NASA directed it toward the distant boundary of the Sun's influence. Beyond the planets lies an enormous bubble called the heliosphere, created by the continuous flow of charged particles streaming outward from the Sun. This vast magnetic shield protects our solar system from much of the high-energy radiation traveling through the Milky Way. For decades, scientists could only estimate where this protective bubble ended. Then Voyager 2 reached it. In 2018, the spacecraft crossed the heliopause, the outer edge of the heliosphere where the solar wind gives way to the thin gas and magnetic environment of interstellar space. This was only the second time a human-made object had entered this unexplored region. The crossing produced remarkable discoveries. Voyager detected a sudden decrease in particles flowing from the Sun while high-energy cosmic rays from outside the solar system increased dramatically. Instruments also measured changes in plasma density and magnetic conditions, providing humanity with its first direct observations of the environment between the stars. Perhaps the biggest surprise was that the boundary wasn't a simple dividing line. Instead of finding a smooth transition, Voyager encountered a complex and constantly changing region where solar material and interstellar matter interact. Magnetic fields twist together, charged particles mix, and enormous plasma waves travel through this invisible frontier. Rather than marking the end of the solar system with a clean border, the heliopause appears to be a dynamic region shaped by conditions both inside and outside the Sun's influence. Every measurement challenged earlier assumptions. Scientists realized that the edge of our solar system behaves more like an active shoreline than a fixed wall. Conditions shift over time, influenced by both the solar cycle and the surrounding interstellar environment. Even after nearly 50 years, Voyager 2 continues to send valuable scientific data home. Although engineers have gradually powered down non-essential systems to conserve electricity from its aging nuclear power source, several instruments remain operational, allowing the spacecraft to continue exploring a region that no dedicated mission has ever visited. Its discoveries have already transformed our understanding of the solar system's outer boundary. But as Voyager 2 travels deeper into the galaxy, it is entering a realm where almost nothing has ever been measured directly. Every signal it returns offers another rare glimpse into one of the least explored regions of space, proving that humanity's oldest interstellar traveler may still have some of its greatest discoveries ahead. After crossing the heliopause, Voyager 2 entered a region that no human spacecraft had explored before. Here, the Sun no longer dominates the environment. Instead, the spacecraft now drifts through the thin gas, magnetic fields, and energetic particles that fill the space between the stars. Although this region appears empty, it is anything but silent. One of Voyager 2's most important discoveries has been the intensity of galactic cosmic rays. These high-energy particles are produced by some of the most violent events in the universe, including exploding stars and other extreme cosmic phenomena. While Earth is protected by both its magnetic field and the Sun's vast magnetic bubble, Voyager now experiences these particles directly. As soon as it crossed into interstellar space, its instruments detected a sharp increase in cosmic radiation. This confirmed that the heliosphere acts as a protective shield, reducing the number of dangerous particles that reach the inner solar system. Understanding this invisible barrier is essential for planning future human missions beyond Earth's neighborhood, where astronauts will require protection from radiation far more intense than anything experienced in low Earth orbit. Voyager 2 has also provided scientists with the first direct measurements of the interstellar plasma surrounding our solar system. Although space is often described as empty, it actually contains an extremely thin mixture of charged particles, magnetic fields, and microscopic dust. By measuring these conditions directly, Voyager is helping researchers understand how our solar system moves through the Milky Way and interacts with its galactic surroundings. These observations are revealing a much more dynamic environment than scientists once imagined. The magnetic fields beyond the heliosphere are not perfectly uniform. They shift over time and interact with the Sun's own magnetic field, creating a constantly changing frontier. Each new transmission from Voyager adds another piece to this puzzle, allowing researchers to improve models of how stellar systems interact with interstellar space. Remarkably, all of this is being accomplished by a spacecraft built with technology from the early 1970s. To extend its life, NASA engineers have gradually turned off heaters and scientific instruments one by one. Every watt of electrical power is precious because Voyager's radioisotope power source naturally loses output each year. Despite these limitations, mission controllers continue to receive data from instruments that have operated far beyond their original design life. One of the most inspiring features aboard Voyager 2 is something that was never intended for scientific research: the golden record. Attached to the spacecraft is a gold-plated copper disc containing sounds, music, greetings in dozens of languages, photographs, and information about life on Earth. It was created as a symbolic message from humanity, intended for any future civilization that might one day discover the spacecraft. The chances of that happening are incredibly small, but the record represents something larger than science. It reflects humanity's desire to communicate, explore, and leave a lasting mark on the universe. Even after its scientific mission eventually ends, Voyager 2 will continue its silent journey around the center of the Milky Way. Long after Earth has changed beyond recognition, the spacecraft will still travel through interstellar space, carrying its message across the galaxy. Communication with Voyager will not last forever. As its power source continues to weaken, more instruments will be switched off until eventually there will no longer be enough energy to operate its transmitter. One day, the final signal will reach Earth, and for the first time in decades, humanity's longest-running exploration mission will fall silent. But silence will not mark the end of Voyager's story. Its discoveries have already transformed our understanding of the outer solar system, the heliosphere, and the environment between the stars. The data returned over nearly half a century will continue to shape scientific research for generations, guiding future missions that travel even farther into deep space. Voyager 2 reminds us that exploration is not measured only by distance. It is measured by curiosity, determination, and the willingness to venture into places no one has ever seen before. Nearly 50 years after launch, this remarkable spacecraft continues to prove that some of humanity's greatest achievements are not built to last forever, but to inspire forever. As Voyager 2 slowly disappears into the vast darkness of the Milky Way, it leaves behind more than scientific discoveries. It leaves a legacy that reminds us the universe is still full of unanswered questions, and that every journey into the unknown begins with the courage to take the first step.